Hello. I want to go over problem number 5 on the homework for this week. This one is the logic is a little difficult to understand, and just wanted to talk about it. Um, so let's go through this. I've went through this several times just to make sure that my logic is correct. They have a formula on how to do this in the example, but it's a little tricky. And if you understand where it comes from, it really doesn't make sense. So let me go through this. Let's do a similar problem. Basically, the way you do this, you look at this, and this is assuming that you understand that this is a two-tailed test, and this is the p-value for a two-tailed test at mean equals 75. Okay, that's your null. This is the alternative that goes with each one of these. So it's like you had this null, this alternative, this null, this alternative, so forth and so on. Okay, and they're saying this report shows the p-value for a two-tailed test. If you're looking at a one-tailed test, which happens to be the first three, you're going to take that p-value and divide it by 2. Okay, and in some cases you got to take that and subtract it from 1, and I'll show you what I'm talking about, hopefully. Here, let's look at this. Mean is less than 75. Well, if it says mean is less than 75, and notice my z is negative, this is appropriate. When I say appropriate, because if you have a less than, you're going to have a negative z. That's good. Okay, in that case, all you got to do is take the p-value divided by 2. I get 0.05 something. Is that p less than my alpha? Was 0.05 less than this? No. So in that case, you have, remember, if p is less than alpha, you reject the null. So in that case, we have insufficient evidence, and we reject the null. We'll do this several times. On the next one, you got mean is less than 75. But notice this time my z is 1.6. That's not appropriate, because your z should be a negative number. Your z is actually a positive number. Remember, if you got less than, your z should be negative. If you got greater than, your z should be positive. So here, since it's less than, and this is positive, this is the one you have to subtract 1 minus whatever that p-value is. So in this instance, I would go, okay, I got 0.1094 is the p-value, right? Well, I want to know the area to the left of 1.6. So basically what you're doing, you're taking 0.1094, divided by 2, which is 0.05 something something, and going 1 minus that, which is like 0.9 something. Well, that p is definitely greater than alpha, so in that case, you're going to reject the null, because you definitely have insufficient evidence. So if it's like this, if this is less than, this should be negative, you know it's automatically going to be insufficient evidence. You can really stop with that logic. Works every time. Here, mean is greater than 75. That's appropriate, 1.6. Okay, all I got to do is look at this. Divided by 2, 0.05 is 0.05 something less than alpha. Yes, p is low, the null has to go. So that means we reject our null, we have sufficient evidence. And last but not least, if it's not equal to, you don't have to do anything to p. You're going to use that actual p-value, and it doesn't matter if it's negative or positive, because if it's not equal to, it could be negative, less than, or greater than. So either is appropriate. So I look at the alpha. Is this p-value less than alpha? No, it's not. If p is low, the null has to go. But in this case, the p is not low, so it's going to be insufficient evidence again. Got it? And again, let's do that again, because I know it's one more time for the road. Again, the logic, less than, negative, appropriate. Less than, negative, appropriate. Take it divided by 2. 0.05 is p. 0.05 less than this? No, insufficient. So this logic works every time. Here, mean is less than 75. That's greater. That's 1 point. That's positive. Not appropriate. I don't have to do any work. I know that's going to be insufficient. You could do that 1 minus deal I told you earlier, but it's just too much work to go through all that, and it's not on a test to calculate that or quiz. Here, same deal, greater than, positive, so that's appropriate. That's appropriate. So here, alpha of 0.07, let's see, 0.1032 divided by 2 is 0.05. Is P, is 0.05 less than that alpha? Yes. So now we finally have one that's sufficient. And not equal to, you don't have to do anything to, you just compare the P to the alpha. Is 0.05 something, is that less than 0.01? No, it's greater than. So with that said, it's insufficient. And that's it. Hopefully that helped. If you have any questions, like always, let me know.